Hello, everyone. Welcome to our webinar on the advancements in protein crystallization software. My name is Lance Ramsey, and I'm the marketing manager here at FORMULATRIX. At any time during the webinar, if you'd like to ask a question, please type it in, as we will have a question and answer session at the end of the presentation. Our speaker today is our application scientist and RockMaker product manager, Dr. Mayank Agarwal. I'm going to pass the controls over to you, Mayank. Alrighty, sir. The floor is yours.
Thanks, Lance. Thank you, everybody, for joining in. A very warm welcome, a very good morning, and a special good afternoon to our friends from Europe. And if there's anybody who's joining in from Australia or New Zealand, a very special thank you to you. I know this is not the most convenient time. Okay, my name is Mayank. I'm the product manager and application scientist at FORMULATRIX, and I am the product manager of basically the RockMaker software. Today, I'm going to talk about the advancements that we have made in this software in the last couple of years. So this is not just a presentation of what we have done, but I'm also going to give you a training demo of a couple of major features that we have added to our software in the past 2 years. And as Lance said, if you have any questions, please feel free to type your questions in the question box, and we'll get to that questions at the end of the presentation. Okay, so the first feature that I wanted to show you was crystal tracking. It's a feature we added, we added it actually 1.5 years ago, but we kept developing it further and further. And this is still an ongoing project, but it's almost entirely done in the latest RockMaker version 3.14. So this is a feature that helps you document your crystals. You know, when the objective of a protein crystallization lab is that you want to grow crystals that you can use to collect diffraction data on, right? And once you have crystals, you store those crystals in certain positions of pucks and store those pucks in dewars and send those dewars to a synchrotron trip. Now, you have to maintain some sort of documentation about which crystal has been a part of which puck and is in which position, right? And most people that I know of use Microsoft Excel for this, and I used to use that too. I used that for 7 years, and it's very, very convenient. It's very useful. It's very easy, to be honest. However, the only problem with this Excel format protocol is that your data is all scattered, especially in academic labs when, you know, people are coming in, people are leaving the lab, then new people come in. Everybody has their own data, everybody has their own files, and those files get scattered over time. So as a PI or as a senior postdoc who's going to be a part of that particular lab for a long time, it's hard for you to know exactly where that raw data is. Even if the protein crystal structure is published, you still may want to go back in time and you know, look at what crystals were sent and which crystals diffracted to which quality, even if they did not get published. So for that, what we are intending to do is we are trying to evolve RockMaker into an electronic notebook. So you can have all your data inside one single piece of software, and then regardless of who comes into the lab, who leaves the lab, you have all the data in one single place. Okay, so this is where this crystal tracking in RockMaker comes into play. And as is with any software, any new program, you have to do some work in the beginning, and then from the next run onwards, things get much, much easier. So I'm going to now walk you through each and every step of crystal tracking, and I'm going to show you how exactly this feature works in RockMaker. The first thing you have to do is create or define pucks and dewars in your lab. So if you are a lab that uses 7 pucks of a certain type and you have 1 dewar, you have to define that stuff in RockMaker. And then you virtually harvest your crystals on the go. And this is just virtual harvesting. I'm not talking about actually picking out crystals from your plates. I'm talking about marking crystals in RockMaker as something that you would like to harvest 4 days from today or 2 days from today or 1 week from today. Once you virtually harvest your crystals, that means you are assigning crystals to certain pucks and certain positions within the pucks. You then define an upcoming synchrotron trip, which what it means is you are virtually harvesting your crystals even before you know there's a trip coming up, and that happens quite a lot. And then once you have a trip coming up, then you would assign all those virtually harvested crystals to that particular trip that you defined, and then print a report as a CSV, which we print as an Excel file in current scenario, or you can print it as a PDF including images of those crystals. Then you take that report to your lab and actually harvest crystals and collect data, and then you can update all those records back into RockMaker. So finally, in your RockMaker, you're going to have all the data about which crystal went where, and whether or not data was collected, when the data was collected, and at what resolution was the data, did you solve the structure. So now I'm going to show you how it works in RockMaker. This is the latest version, 3.14.5. And this is a lysozyme screen experiment, of course. And the first thing you have to do, as I said, was if you have RockMaker Enterprise. Now this is something that you might want to note. This feature is only available if you have RockMaker Enterprise. For imaging and design editions, you won't have access to this. You would notice if you have RockMaker Enterprise, and if you have somewhere around 3.14 versions, you would notice there's a new node called Crystal Container under Setup. So you open that up, and as I said in my presentation, you have to define all the pucks and doers that you have in your lab. I've already done that here, but I'm just going to show you how to do it. So right-click in the pucks definition window and click Add, and here I'm just going to define it as puck 5 and give it a unique barcode. It could be anything, and then define the assign a puck type. So right now we only have 4 default puck types in the database, but if there's any puck type that you use and we don't have, you just let us know and we'll add it to our RockMaker, next version of the RockMaker. So let's say you select spine puck. We know a spine puck can take 10 pins, so that's automatically populated, and all the 10 pins are right now available because all these positions are empty. There's no crystal assigned to any of these positions in puck 5. And then you would define a doer in a similar way. So right click, add, and let's call it doer number 4, and this can take, let's say, 10 pucks, and then that's it. You will then click on the save button. Okay. Now we can go back to our experiment. As I said, once you have defined your pucks and doers, this is the only one time that you have to do. From here on, whenever you have a new set of crystals, you don't have to keep defining your pucks and doers. What you have to do though is, once you have defined your pucks and doers, and even though you do not know if there is a new synchrotron trip coming up, that's fine. What you will do is you'll go through any experiment that you have set up in the recent past, any experiment that you think might yield a crystal and you would like to send those crystals, open that experiment up and just go through each and every drop of that crystal. And as you find a crystal, let's look for a few crystals. So as you find a crystal, and this is not the best looking crystal I know, but let's just harvest it. So under Images tab, go to Drops, and in here you'll find a new icon called Harvest Crystal. You click this and draw a box around a crystal that you want to harvest. Now this is what I call virtually harvesting crystals. You're not really harvesting it, but you're marking these crystals in RockMaker as being harvested. So when you draw this box, a new window would pop up. This is called crystal definition, and most of the information is already filled in, like what's the crystal ID, what's the crystal name, which means this is the plate number, well number, drop number, and crystal number. So, and the project details, experiment details, everything is already filled in except for the cryoprotectant data and soaking. If you are really meticulous with your documentation, which I always advise people to be, because that's the whole objective of moving towards an electronic notebook, you should enter as much data as you can. So enter details about the cryoprotectant and soaking. If you don't know it yet, don't worry about it. If you don't want to enter it, it's not mandatory. This is the real important fields that you have to play around with. So we don't know what synchrotron trip we are going to send it to. So leave it blank. And we know that we are going to start harvesting our crystals a week from today, even though we don't know where those crystals are going, but we just want to freeze them and make them ready for the next trip that is coming up. So we'll assign it to doer 1 and puck 1, and it automatically picks up position 1 because that's the first available position. And apply. And then let's click on, let's harvest a different crystal. Let's harvest this crystal right here. Again, it automatically assigns it doer 1 and puck 1, position number 2, because that's the next available position. And if you want a different position, what you do is click on this puck diagram here, and you can select whichever. It's like a seat selection on an airplane. basically. And the red icon here means this is already taken. Okay, now let's move on to the next drop. Next crystal. I'm going to harvest, I know you get the point, but I'm going to harvest a few crystals so I can show you the next step. So this is a crystal. We'll harvest this, assign it to again doer 1, puck 1, apply, and let's do this for a couple more drops, for a couple more crystals. So here, this is nice. Doer 1, puck 1, apply, and this will automatically go to doer 1, puck 1, position 5, apply. Now, let's say that you have harvested all the crystals that you can, and they are all assigned to one single puck, or many pucks for that matter. And now is the time for a synchrotron trip, right? So let's say there's a synchrotron trip coming up in the month of, next month in July. So notice there's a new tab here called crystal tracking, a new node. You go here, right click and say new trip, new synchrotron trip, and we'll define this new trip. So let's call it, let's say you want to send your crystals to APS in Chicago. So APS July 2019. And here I'm going to give it a collection date of July 6th. Now again, these details, if you want, you can enter them. They are not mandatory. So if you want to enter details about the beam line, about the detector type, if there's a contact person at the beam line who's going to help you, you can enter those details here. And notice in the bottom tab, in the bottom table, you don't have any crystals because we haven't assigned any crystals to this trip yet. Okay, so now we'll just save this trip, and the trip is still empty. But go back to the crystal container and see that there's puck 1, which is now assigned to doer 1, and it has only 11 available pins because 5 are already taken by the 5 crystals that we just assigned. And this is in use. However, this doer 1 is not in use because this is not assigned to any trip. This is not going anywhere. So what you will do is assign it to Synchrotron Trip, like that. And then in the in-use checkbox is already ticked, and you will save it now. Okay, so the next step is now you have assigned crystals to pins, to puck, to doer, and to a synchrotron trip, but you haven't really harvested crystals. So let's say you want to harvest your crystals now. So what you'll have to do is print a report. So when you are in this synchrotron trip tab, you'll print a synchrotron trip report. Click here. And I'm going to show you, there are 2 ways you can print this report, as a CSV or as a PDF. So I'm going to show you how the PDF looks like, but it's really the CSV that we are going to work with. So this is what the PDF will look like. You'll have images for each of the drops each of the crystals that you harvested, and within the drop, the box that you drew will also appear, and it's going to show you exactly where this crystal is supposed to go. So this will go in doer 1, puck 1, position 1. This will go in doer 1, puck 1, position 2, and so forth. And then you also have details about your project, about your experiment, which plate you have to pick. So you can move over to your rock imager and pick out that plate, and then take that plate to your cold room or wherever you want to harvest these crystals, and then start harvesting. But which crystal is supposed to go where? For that, you will need to print out a report, and this PDF format will take a lot more pages. So if you want to conserve that, if you are more used to using an Excel file, what you'll have to do is print a report as a CSV. So I'm going to export this as a CSV, and let's just save it here. Now I'm going to open up that report and show you how it looks like. So this is a format that is hopefully more you are more used to seeing this format. So the first row here is the title, which says Crystal ID, Synchrotron Trip ID, Trip name, doer name, puck name, and so on and so forth. If you remember, we harvested 5 crystals. That's where they are. Each of them have a unique crystal ID, and they are going in doer 1, puck 1, position 1, 2, 3, 4, 5. Now you'll print this report, take it to your lab, and start harvesting crystals and start putting those crystals in these positions. Of course, when you are doing that, many times, almost every time, you will destroy a crystal, right? Or you'll drop a crystal, or we'll just kill the crystal while we are harvesting it. So let's say crystal number 4 or position number 4, or actually crystal number 3098, which is position 3, let's say we destroyed that crystal. All you have to do is delete this row. So select the row and delete it. And now what that means is crystal 3099, which was supposed to go in position 4, will now go to position 3, right? So all you have to do is just renumber these positions and print this report out, send it to the synchrotron along with your doers and your pucks, and in there, if you have a personnel there, they will enter the dates of screening, the dates of data collection, and while you are collecting data, a lot of times people just simultaneously also start working on their data resolution, data solving, right? That you start using HKL and Phoenix. So you would know right away what the resolution is, or what resolution is the crystals diffracting at. So you'll enter that data here as well. So let's say this crystal diffracted to 1.5, 2.5, 2.3, and 1. You can also enter details about the quality if you want, and the structure URL. So let's say you published your crystal structure later. You can also enter the URL of the crystal structure right here from the PDB database, and then this file would be imported back into RockMaker. So all this data that you entered here, all the changes that you made, by changes I mean deleting the third row, the third position, and replacing it with number 4. All of that will be uploaded back into RockMaker, and all those changes will take effect there. So I'm gonna save it, and now I'm gonna show you how to import this report back into RockMaker. So let's just save it, and yes, and I'll open RockMaker back again, and let's go to our crystal container here, and our synchrotron trip. So in the trip, you see that there are 5 crystals assigned, and that's because these were the crystals we initially harvested. Now here you'll see a button called Import Crystal CSV. You click here, Browse File, and now we are going to import all this data. And see, it tells you right away that there are some changes to this file which do not match with the changes with the original file that you exported, which is fine. This is what we did. We deleted the third row. So we are going to import this back, and now all these changes will take effect in the crystals that you harvested. So I'm going to show you back here. Now if I open this experiment again, and let's open up, and maybe I have to close this experiment and reopen it. So when you open the experiment again, I'm going to show you a couple of drops which we harvested. So let's say this one, edit crystal, and you see the resolution data is already entered here. That's because this data was imported from that CSV file. So this is how this whole feature works. And once you are done, you can print out a Synchrotron Trip report as a PDF for your record keeping if you like. You can also use the search and filter, which I'll not go into today, but you can also use the search and filter, which comes in as a part of RockMaker Enterprise, to know exactly which crystals you harvested, which pins they were a part of, and whether or not data was collected. Okay, going back to the presentation and moving on to the next feature, Marco. Now this is, I believe, the biggest feature that we have implemented in RockMaker in the last few years, not just 2. And that's because this is an auto-scoring algorithm which has been making a lot of buzz in the market. It stands for Machine Recognition of Crystallization Outcomes. This is an algorithm written by employees from Google along with a consortium of 5 different labs in US, Europe, and Australia. And this algorithm works on visible light path. So the whole workflow is that you collect images from your Rock Imager, and those images will then go to this Marco algorithm. They will get scored, and then the scores will be returned back to your RockMaker. And you can see those scores from Marco in your RockMaker along with your images. Now this only works with visible light path as of now. And it only works automatically if you install it for any inspections that you collect after installing Marco. So if you have older inspections that you had before you installed Marco on your computer, those will have to be manually scored by, or those will have to be manually sent to Marco by clicking a button. We have a button for that. I'm going to show you that. And The scores that you get from Marco, they actually represent the probability of presence of a crystal in each image. They don't discretely tell you whether or not you have a crystal, whether or not it's a clear image or a precipitate or something else. It just gives you a probability. Now it's up to you to define what you think is a good score. I'm going to show you that as well, how you can do that in RockMaker. But this Marco algorithm is not this is not our private property. This does not have any intellectual property rights from FORMULATRIX. This is an open source algorithm, so you can install it on your computers if you want. However, what we have done is we have integrated Marco with RockMaker, so the workflow is much smoother. You don't have to copy paste images from RockMaker and send it to Marco, which is a different computer. This all will work in tandem. So as you keep collecting images, they will keep getting scored by Marco. And now I'm going to show you a video that and thank you Scott Lovell from University of Kansas for allowing me to make this video. I'm going to show you this video which shows how Marco exactly works for a user. So it's pretty straightforward. What I'm doing here is I'm going to image this plate, and this is an RI2. So maybe this is a little unfamiliar to you guys who have rock imager hotels, but I'm going to image this certain plate, and this is RockMaker. This is an experiment design view, and once you get those images back, you can see on the top right corner of each image there is a red or green icon. This is basically a score given by Marco to each of these images. I'm going to zoom in to these, but before that I'm going to show you an image, a score view. So this is something that people find very, very useful. So when you switch to score view, you see each of these drops, the images have disappeared, and all you see are scores. And as I said before, Marco does not tell you discretely whether you have a crystal or not. It just gives you probabilities, and it's up to the user to define what is a good probability for that user. So in this particular case, a good probability was defined as a score of 0.8. So any score above 0.8 is colored as green. So this saves a lot of time for the user because you already have scores and you know exactly which drops to focus more on when you switch to score view. So any green drops that you would click on will most likely have a crystal. And Marco has an efficiency of about 94% in visible light path. So I'm going to show you a few examples of how well Marco scores. So let's say we want to open up this drop of 0.94. And you see there are crystals in here. I'm going to show you a few more drops. So 0.95, this is something I found very interesting. This is a crystal that is not easily and quickly discernible, but Marco still found it. So this is 0.94. This is a quite clear visible crystal. Now this is a drop that was scored quite low, a 0.25, and as you could see, there was no crystal in here. So even though you do see a little speck here, Marco is intelligent enough to distinguish this from a crystal. Okay, so that's how Marco works. And going back to the presentation now. As I said, Marco only works with visible light path, which is why what we are also doing is trying to improve Marco behind the scenes. So this is what we call the Marco Improvement Program. This is a future project. I mean, this is a project that is currently going on, and we don't know what I cannot promise you any end date on when this is going to be integrated, when this is going to be implemented. But what we are doing basically is making Marco more versatile and more accurate. Even though it still has an accuracy of 94% in visible light path, we are trying to enhance its accuracy even further, if that's even possible. However, as is true with anything, this is just a piece of software, right? So you are always going to have a few false positives and a few false negatives every now and then, but our objective is to minimize the number of false negatives that you, the number of false positives that you get and number of false negatives that you get. More importantly, number of false negatives. Okay, other than that, the other improvement that we are trying to do is making Marco more versatile. By versatility, I mean making Marco score images from UV, MFI, or multifluorescence imaging, and sonic as well. This project might take a while because for that we need lots and lots of images, and we are not a research lab, so this is where we depend on our customers. So any clients who are voluntarily willing to participate in this Marco improvement program will send us images every now and then, and those images will then be used to improve this Marco algorithm by training and retraining the algorithm that we currently have. We also have a feature called dispute in RockMaker. So any score of Marco that you are not satisfied with, which you think Marco missed, you can click a button in RockMaker, which will then, what it will do, it's basically like disputing a certain score. So that image along with your comments will be sent back to us, and we'll use those images to improve Marco even further. Okay, I forgot to show you how exactly you have to send images to Marco. So here you'll see a button called Send to Marco. For any new inspections that you collect after you install Marco on your computer, this will automatically be done unless you disable it. But for any old inspections that you collected before you installed Marco, you can just click this button and the whole plate will be sent to Marco. Alternatively, you can also select multiple plates from the Explorer and just right click and say Send to Marco, and that will also send those plates to, so it's here, Send to Autoscore. This will also send the plates to Marco scoring algorithm. And while you are viewing a score, you can also dispute the score if you don't like it by clicking on this dispute button. Okay. The third feature I want to show you, the third major feature I want to show you is the iterative screen optimization. And this is a research article published in ACTA-F by Jason McClellan from University of Austin. I think this research was done when he was in Dartmouth, but now they have moved to UT Austin. So thank you, Jason, very much for this. Now I'm going to talk a little bit about this. We've all seen as crystallographers this solubility curve many, many times. What it shows is at a certain protein concentration, if you keep increasing the concentration of precipitating agent of the precipitant, you are going to go from a clear drop into a metastable zone, into a nucleation zone where crystallization happens. And if you keep increasing the precipitant concentration, you'll get precipitate. So basically the idea is that you have to find the optimal amount of optimal concentration of the precipitant in your well solution at which you will enter this nucleation zone for your protein. In other words, if you have a very high concentration of precipitant, what you want to do is you'll get a precipitate. So what you want to do is reduce the concentration of precipitant so you enter the nucleation zone, or if you have a clear drop, which means you have a very low concentration of precipitant, you want to increase the precipitant concentration so you can again move into the nucleation zone. So this can be done automatically if you have a formulator and if you have a RockMaker Enterprise. Again, this is a feature that is available for RockMaker Enterprise. So for that, you will have to obviously score your drops first. You have to score all your images based on 4 categories. You define them as clear, crystal, light precipitate, or heavy precipitate. So any drop that was scored as clear will what RockMaker will do is automatically create a new experiment, and in that new experiment, any drop that was scored as clear in the previous experiment will have a precipitant concentration that is increased by a certain percentage. Similarly, if you have a light precipitate or a heavy precipitate, in the next experiment that forms, the concentration of precipitant will be reduced by a certain percentage. If you have a crystal, then the precipitant concentration will not be changed, and obviously you would not want to change it anyway. So I'm going to give you a little demo of this as well. I'm going back to this experiment of mine, and I have already scored all these drops as A, B, C, or D, which means clear, crystal as B, C is light precipitate, and D is heavy precipitate. So I've already scored all these images. We have also actually implemented this score because we realize that not everybody would like to score using A, B, C, D. So what we have also done is if you are more used to using the 0 to 9 scoring group, which has been around in RockMaker since forever, you can do that as well. So you can also score your images as 0 to 9. 0 is clear and 9 is crystal. You can also do that. It's up to you. So I'm going to show you how this really works. So we have an ISO percentage for every score, every manual default score. So if it's a clear drop, the ISO percentage is 10%, which means if you get a clear drop, the next experiment that gets created will have a precipitant concentration of increased by 10%. And similarly, all these values would work. So if you have a microcrystal, or if you have a needle or a plate or a crystal, the precipitant concentration will not be changed. As an example, so let's say this is a screen. This is an experiment that you just scored, and you want to create an ISO out of it, an iterative screen optimization out of it. Of course, this is not an ideal experiment because you already have crystals, so why would you want to do it? But let's just say you want to do it. What you would do then is go to the design, experiment design, and click on this optimization button. And most of you guys are used to using the grid layer optimization, wherein you optimize one condition along rows and the other condition along columns. But in this case, you'll select iterative screen and click on next. And now it asks you, just to make sure that is this really what you want to do? Do you want to increase the precipitant concentration by 10% for clear drops, and by reduce them by 5% for dust or granular precipitate, and so on and so forth. If you want to make any changes, you can make those changes here. If this is good, then you just click next. And this is what so it's going to create the same experiment with a suffix of _ISO1. And this is called ISO because this is called iterative because it really is iterative. You can keep doing it after ISO1 on the ISO1 plate to create an ISO2 plate and then an ISO3 plate until you get a crystal. And I urge you to go through that article that I mentioned in my presentation by Jason McClellan's lab. It talks more in detail about how exactly this works, and the results are phenomenal. They were able to get crystals from conditions that initially yielded nothing. Okay, so then you click on optimize. And now, as I said, a new experiment will get created. In my presentation, I mentioned that this is mostly useful for optimizing up to 34 ingredients screen. And the reason I say that is because this works with Formulator, which is a liquid handler from FORMULATRIX. And FORMULATRIX, a formulator comes with up to a 34 ingredient slot. So if you have more than 34 ingredients, you cannot use the formulator. And because you cannot use the formulator, the optimization will not work, or it will just take a lot of time. Okay, so your experiment is now created. Now let's look at that experiment, and I'm going to show you what exactly happened there. So going back to the original experiment. So this drop was scored as a 0, which means as a clear drop, right? And this had a precipitant concentration of, actually maybe this is a better way. So this had a precipitant concentration of 30% MPD and 0.02 calcium chloride. When we look at the new experiment that got created, the MPD concentration increased from 30% to 33%. That's a 10% increase. And it did not change the salt concentration because the salt is not defined as a precipitant. So it alters only the concentration of precipitants. If there are multiple precipitants, it will change the concentration of all those precipitants. I'll give you another example. So let's say this one, precipitate. Okay. So this has a precipitant concentration of 4 molar. So what we want to do is reduce the concentration by 10%. So let's see what happens here. So there you go. The concentration was decreased by a huge amount here as well. Am I looking at the right? No, I'm not looking at the right well. So T9, this one. Here we went from 4 to 3.6, a reduction of 10%. So this is how ISO works, and as I said, you can keep creating these ISOs in iterations. So you can keep creating ISO 1, 2, 3, 4 until you get a crystal. Okay, moving on. So these were the 3 major features that we have implemented in RockMaker. And there are some minor changes and minor improvements as well that we made. There's a feature called points of interest that we recently implemented. And this was requested by a couple of labs, and we really found it interesting. What it does is you can assign a certain, you can pick certain coordinates within the drop image, and you can export the coordinates of those points into an Excel file, and then those coordinates will be read by a third-party software to carry out different functionalities. Like for example, if you want to do ligand soaking automatically, there are instruments out there which you can use to automatically soak your crystal, to automatically add a certain ligand within a certain position of a drop. Now, how would it know exactly where to drop that ligand? That's where the points of interest come into play. And also, if you want to collect if you want to automatically collect data, right, on diffraction data on your crystals, what you will do is you'll assign certain points of interest onto your crystal and then export those points of interest and then load your plate onto whichever diffractometer can take that plate, and then based on what the coordinates are, the diffraction data will be collected on that particular point within the drop. Then we have also added the undo redo functionality in RockMaker. This is something that had been requested for many years. We finally have it. This is, however, this still doesn't work as we really would like it to work, but because it doesn't, you cannot undo everything and redo everything in RockMaker. There are only a few things that you can do, that you can undo or redo. So this is an ongoing project as well, but we have tried to cover everything that is that you are more likely to places where people are more likely to make mistakes. They can now be undone and redone. We have an improved image now and disable imaging buttons, and image now and disable imaging can now also be used in RockMaker Web. So I'm going to show you what I mean by improved. When you open up an experiment, I don't know if you remember, if you have noticed, we now only have two buttons, one for image now and one for disable imaging. Initially or previously we used to have 3 buttons for image now. So this is just a little bit of cleanup that we are doing in RockMaker. We also have a RockMaker University, which is mostly useful for people who are really new to RockMaker. So there's a button within RockMaker I'm going to show you in a second, which you can click, and this RockMaker University is like an interactive help. It's going to help you create experiments and walk you through every step of the workflow that you are used to in a crystallization lab. We also have an automatic image management now. This has been there for about 2 years. We had image management for a long time, and what it does is you can clear out old images and old focus levels of expired plates, but now we have an automatic image management, which means you don't even have to run RockMaker. So you can start this cleanup process of cleaning out all the old images because it takes a lot of space, and a lot of people don't like having focus levels from images that are 6 years old or more than 6 months old. So you can do all that stuff in an automatic fashion. You don't have to wait for that function to finish up before you can start using RockMaker. This can all be handled automatically. Now, RockMaker University. So this is the button for RockMaker University under Home, and this is available for Design Edition, for Enterprise Edition, and for Imaging Edition as well. So all of you can use it. However, the functionality will be disabled based on which version you have, which edition you have. So that's about it. With that, I conclude my talk. And if you have any questions, I'll be more than happy to answer. Over to you, Lance.
Hey, Mayank. Thank you so much for that presentation. So we have quite a few questions that have come in. I'm going to group everything by feature. So starting with crystal tracking. Can you use crystal tracking for canes?
Right now you cannot, but that's a suggestion that was made to us a few months ago. So we can start working on that as well if you are interested. Yes, there's nothing that stops it from using it with canes.
Okay, so a future feature add-on.
Yeah.
Also with crystal tracking, I see details for soaking, but what about co-crystallization?
So for co-crystallization, it works in a different way. What you're really supposed to do is, I'm sure, can you still see my screen, Lance?
Yes, yep, coming in.
Okay. So for co-crystallization, what is usually the best way is, let's say you have a protein formulation which is defined as, hen egg white lysozyme, and let's say you want to co-crystallize it with a ligand called ligand 1. What you'll do is when you define your protein, in here you right-click and say new ingredient, and then define the type as, not DNA, ligand, and then you'll say ligand 1. And if you want to enter more details, you can. If you don't, then you can leave it, let it be, and just save it. So now when you drag and drop this protein into your experiment, it already has the details of what exactly the protein formulation contains. It's a co-crystal because it also has a protein, and it has a protein as well as a compound. So that's how co-crystallization works. I should also add, having said that, we are also working on a new feature which is called multiple fragment addition in RockMaker, because this has been requested for a few months now, that industries, large industries and academic labs which work with a large number of fragments, they would like to use this co-crystallization method, but they don't want to create 1,000 new protein formulations, one for each ligand. So for that, what we are doing is we are trying to implement a feature which will enable you to add all those thousands of fragments as an Excel file. Well, you have them as a list in an Excel file, and you can upload them all. You can upload that Excel file basically, or you can import the data from the Excel file into RockMaker, and that will make things more seamless. I wish I could show you a few mock-ups that I have, but I think this is not the right place for it, and we don't have enough time. But we are working on that as well.
All right, next question here. Can you use crystal tracking for plates outside of Rock Imager, such as plates 24 well or 15 well plates?
So no, you can't. Any plate that you can define in RockMaker, ideally you can use crystal tracking, but that plate has to have images. So if you have images, then yes, you can use it. So any plate with an SPS footprint, any plate that was defined in RockMaker, you can use it.
All right. How do you differentiate between a storage and shipping door with crystal tracking?
We don't. We don't. So because I think in my experience, I've always seen people store using the storage door also as the shipping door. If that is different in a certain case, we can talk about that offline, and we'll figure out a way on how to deal with that.
All right, next question here. Again on crystal tracking, is the CSV file iSpy-B compatible for the diamond light source?
Not sure. I haven't used that software. But if that can take Excel files, it should be able to take CSV files as well. CSV is a very general format. I'd be surprised if it can't. And if it can take Excel files, what you can do is convert the CSV into an Excel file. That's easy.
All right, the next two questions are about reporting for crystal tracking. Can you add custom parameters or columns to report, such as plate ID, or also add the well and drop position?
Yes, we can do that. Right now it's not in there, but if there are more columns that you would like, please give us some feedback. You can write to me directly, and Lance, every one of you will receive my email ID after the webinar, and you can write to me directly, and I'll log those requests, and we can surely add those columns in that Excel file. Sure.
All right, shifting gears over to Marco. How do I get the Marco feature installed for my lab?
Okay, so as I said, for eligibility, you have to be on maintenance for Marco as of the release of the Marco. So right now Marco is not released. Okay, well, let me begin with that. We are beta testing it at a few client sites, and the plan as of now is that Marco will be released to everyone in the early next month. However, if something goes wrong during our beta testing, which we haven't faced any major issue as of now, but if anything delays the release of Marco, then whichever version Marco will be a part of, you can have access to it if you are on maintenance on that date. Now, once you have upgraded your RockMaker to the latest version which supports Marco, then you have to install Marco on a Linux machine. And this is one thing I did not talk about during my presentation because I wasn't sure if I should. But now since you have brought it up, one limitation of Marco is, or not limitation, a sort of a hiccup is that you have to install Marco on a Linux environment. This is not a problem for any of the clients that I've talked to, because most institutes have a Linux machine lying around. So if you have a Linux machine, as long as it's on the same network as your RockMaker computer, it should work fine. You have to install Marco on that Linux. We'll send out the requirements for the Linux machine, and we'll also send out the installation steps in great detail once we are close to the release of Marco. If you want them early on, you can email me and I'll send you those details later after the webinar. But yeah, you are supposed to install Marco by yourself, and it's really straightforward. Your IT will have to be involved, of course. And once you have done that, all you have to do is enable Marco in RockMaker and enter the IP address of that Linux machine in RockMaker. Then this integration will work seamlessly. So that's how this would go on.
All right. Also on Marco here, can Marco be used to group poor scores to isolate conditions that don't work, such as pH, additive, and precipitant?
Not as of now.
Again on Marco, can the Marco score be overlaid over the visible light view on the plate, perhaps in the corner, so the score and the image can be seen at the same time?
You can do that in the overlaid. I don't know exactly what you mean by overlay, but you still have that functionality, right? So if I show you this experiment, you see on the top right, you see a score. This is how exactly Marco's score would appear. I don't exactly know what you mean by overlay.
Maybe we can follow up.
Are you maybe what the user is asking is, in the score view, when you see these large scores, can you also have a slightly dimmed image behind these scores? Well, that would be a new feature. We haven't thought about it. We are not sure. If I'm understanding you right, if this is what you want, this is something we haven't thought about. It might make things crowded, but it surely needs more thought. So I can't answer that right now. But what we are also trying to do is, in the upcoming versions of Marco, because we are continuously going to make improvements to Marco, and in one of those future versions, we are going to have a system wherein you can select multiple plates that were scored by Marco and click on a button, and all the images within those experiments will be arranged in a descending order of Marco score. So you can go from the highest Marco scored image to the lowest Marco scored images. We don't have a UI for that yet. We don't have mockups for that yet, but this is still a thought in progress.
Okay, switching gears over to automatic image management. When will the automatic image management feature be available, and what version of RockMaker is necessary?
It's already available. I'm sorry if I wasn't clear. It's been around for about 2 years now. I just wanted to make sure that everybody knows about it. So the way you use it is under imaging in your Explorer view, you have this image management, right? So there are two, I only have two protocols defined, but let me just walk you through one of these. So let's say you want to delete images from all the expired plates. So you open this up, and this is already defined, so you don't really have to do anything. You have to still define your search paths. So let's say in all my projects, I want to clear all the images that were older than 180 days. So all I have to do is start this process. I'm not going to do it now, but all I have to do is start this process, and then I don't even have to open RockMaker. I can just close RockMaker. It's going to start running this clearing of old images in the background. That's what I meant by automatic image management.
Okay, we have a few more questions here, but we're running a little bit short on time. If you asked a question that wasn't answered during the session, we will follow up with you individually. And with that, we'd like to close out this session. Thank you, everyone, for joining us today. And so have a great rest of your day. Thank you, everyone.
Thanks, everyone. Thanks, Lance. Bye.